When you pour a glass of water, it looks completely clear. No color, no shade of blue, nothing. But as soon as you look out over the ocean, suddenly you're staring at a deep, rich blue that stretches beyond the horizon. How can it be the same substance? How can water be both transparent and intensely blue? The answer isn't a trick of the eye. It's the result of real physics based on how light interacts with water. Sunlight isn't actually white, even though it looks that way. It's made up of a spectrum of colors, from red and orange to green, blue, and violet. Each color corresponds to a specific wavelength, and when light hits the surface of the ocean, those wavelengths don't behave the same way. Water absorbs light unevenly. The longer wavelengths, like red, orange, and yellow, are absorbed very quickly, sometimes within just a few meters. Shorter wavelengths, like blue and violet, penetrate much deeper. They scatter and reflect back to your eyes. That's why the ocean appears blue. Water itself isn't blue, but its molecules absorb the warmer colors and allow the cooler ones, especially blue, to pass through. What you're seeing when you look at the sea is the leftover light. After most of the spectrum has been filtered out, that leftover is mostly blue. If you were to dive underwater and look around at depths beyond 20 or 30 meters, you'd notice that most colors start to disappear. Red objects begin to look gray, orange fades, and eventually only blue remains. That's why scuba divers and underwater filmmakers use intense red lights to bring back the natural colors that the ocean has absorbed. The ocean isn't just blue from the outside, it's blue from within. But in a glass of water, the effect is too weak to notice. The distance the light travels is tiny, so the spectrum remains largely intact. It's only when you have tens or hundreds of meters of water that the filtering becomes obvious. The deeper the water, the bluer it gets. Other factors also influence how the ocean looks. In shallow tropical areas, water may appear turquoise or even green. That's not just because of depth, but also because of things like sand, limestone, coral reefs, and microscopic plankton. These particles scatter light in unique ways, giving the water its vivid color. In seas rich in organic matter, the water often looks green. In pristine, open ocean regions, it looks dark blue. You've probably heard that the ocean looks blue because it reflects the sky. And yes, that's partly true, but only to a small extent. Scientific studies have confirmed that the majority of the ocean's color comes from how water absorbs and scatters light, not from reflections. Even on cloudy days, the ocean remains blue. And if you dive underwater, you'll find that the blue doesn't go away. No sky required. So the next time you're standing on the shore, staring out at the blue horizon, remember, it's not a trick and it's not a mystery. It's science. The ocean's color is a perfect example of how light, matter, and your eyes all work together to create something beautiful. Sometimes, the most fascinating phenomena don't happen in deep space, but in an ordinary glass of water. For more fascinating videos, make sure to like and subscribe to our channel, Almost Fiction.